The graph of the piecewise linear function f of x is shown to the right. Okay, f of x. Find the value of integral -1 to 9 to f of x minus 1. Okay, so I'm going to rewrite this a little bit. I'm going to move the 2 to the outside. Nope, that's a terrible 9. There we go. 9 f of x dx minus, and then I just separate the integral, and there's a 1 in there. Okay? Okay. So now we can see, sort of, that this is area under the curve. Under the curve. And then this we can just calculate. So first thing we're going to do then is find area under the curve using my cyan baby blue. So 1, 2, 3. 3 times, was it 1? 1, 1. Okay. So 3 times 1 is 3. Divided by 2 is 1.5. 1, 2, 3. Negative 1. This is 1, 3. Oh, that's 0. Okay. So then we have negative 1.5. So since we have positive 1.5, negative 1.5, when their powers combine, we have nothing. Looking at this then, we have 2. This goes 1, 2, 3, 4. So we have 4 by 2, which is 8. So that equals 8. So rewriting it, we know that the integral from -1 to 9 of f of x dx is 8, because that's the area under the curve, which is the definition of an integral, pretty much, mostly. 2 times 8 minus integral of 1 is x, -1 to 9. We could also graph this and calculate it that way. So if you want to look at the graph of this, this would just be 1. And so you'd be like, oh, -1, 9, distance of 10, height of 1. That's probably going to be 20. Or 10. 10. So we have 16 minus quantity 9 minus -1, which is 10. So it's 10, 16, minus 10, which is 6. So the answer will be 6, which is even a possible answer, which is nice. Oop, add some perspective, make it a little cube. There we go, 6. All right, recap. We're given an equation. We can then separate it out to make it more understandable. And we wanted to isolate the integral of f of x dx because we know that integral of f of x dx is the area under the curve, which we can calculate because all we have is straight lines, which then makes triangles and squares, rectangles if you will. And then the little part that's left over, the -1, we can just integrate. Or if we wanted to, we could regraph that. And we solve the integral piece by piece. And that's how we do piecewise area under the